Alright, I'm going to do example number 2. The first 3 examples are very similar to each other, so I'm just going to tell you one general thing. Here's what you need to know. Alright, write this down. The key word is comparing. It's all comparing. So therefore, let's go to this little thing I wrote out. When you're comparing graphs to the parent, right? You got one of these graphs. How do you compare this to the parent? Basically, you're looking for A. You're looking at A and saying, okay, A determines something. H determines something. You guys know what H and K determine. I already told you H and K are they make up the vertex, right? What does A do? Well, A actually makes this V wider, narrower, okay, stuff like that. So here's the things that I need you to know. 4 things. Whenever I say the word compare, these are the 4 things I want. Number 1, is it a vertical shrink or a vertical stretch? You have to have those words, vertical shrink, vertical stretch. How do you know? Well, if you graphed it, you would know, okay? But if the absolute value of A is less than 1, okay, then it's a shrink. If the absolute value of the A, whatever A is greater than 1, then it's a stretch, meaning this. Okay, absolute value of A less than 1. So Y, I'm going to make one up. Y equals A, we'll say 1/2 times X minus 1. Okay, look at this A. A is 1/2, right? I put 1/2 here. 1/2, absolute value of 1/2 is, I even make it negative 1/2. Put negative 1/2 here. Absolute value of negative 1/2 is 1/2, which is less than 1. Okay, that means you would write down this is a vertical shrink just by looking at the A. If A is greater than 1, obviously if Y equals 3 times the absolute value of X plus 1. Okay, so look at the A. Oh, that's greater than 1. What if I put negative 3? Would that still work here? Yes. Absolute value of negative 3 is still greater than 1. So either way, 3 or negative 3, it's still a stretch. Okay? Alright, so what this will look like is it'll look wider. See this V? See how wide it looks? Okay? It normally looks like this way, but now it's wider. Okay? What happens when you make the numbers go up? 3, 4, 5, 6, 7. It actually gets like, it looks skinnier, right? It will look like more like this. You see how skinny that looks? Okay, we call that a vertical stretch. Alright, this is wider, this is getting skinnier, or vertically it's actually stretching out. It's getting vertically taller, it's stretching. Okay, down here, this guy, he's shrinking down vertically, he shrunk down. Okay, that's why it's a shrink and a stretch. Next one, is it wider or narrow? That's the easier one to get. Oh, this one looks wider than the parent. So that's still, when the absolute value of A is less than 1, it is wider. So this absolute value of A is less than 1. You would say it's wider, 1, and it's a vertical shrink. Those 2 things so far. Okay? Narrower, this would actually, this equation, you'd look at that and say, okay, that would be narrower than the parent because absolute value A is greater than 1. Alright? Now, is it a reflection across the x-axis? That's another thing. 1, is it a shrink or stretch? 2, is it wider or narrower? Number 3, you'll say, yes, it's a reflection over the x-axis. Or you would say, no, it's not a reflection. Or just leave it blank. But you'd have to say if it was. How do you know if it's a reflection? Remember how the parent was? The parent looked like this? Something like this, right? What is a reflection? A mirror does what? It reflects it the other way. Okay? So it flipped down. Okay? So it reflected across the x-axis. That's what it did. When does it do this? When does it go down? When A is negative. Okay? Get that, write that down. When A is negative, it is a reflection. Last one. How did it translate? Oh, it went 2 to the left and 1 up. Just like example number 1, we said, I forget what it was. It went, left 4 and down 2, I think it was. You would say it translated left 4 and down 2. Have to have that word in there, okay? That's how you compare graphs. These 4 ideas, write them all down, one or the other, okay? So let's go back to this and check it out. All you're doing is comparing this with the parent, y equals absolute value of x, and then you're going to compare this with the parent. Okay, these are actually two separate questions. I don't even have to graph these things to compare, honestly. If you know those four things I just wrote down, or you just wrote down, alright, this a is less than 1. Absolute value of a is less than 1. I know it's gonna be wider, okay? It's gonna be wider. It's gonna be a vertical shrink. There's 2. Is it a reflection? No. It's just positive, so it still goes up. Okay? Lastly, did it translate? Do you see an h and a k here? Do you see x plus h or minus h plus k? No. So therefore, it didn't translate. Okay, you would say that. It didn't translate. So, number 1, you would say it's a vertical shrink. That's say vertical. Number 2, it is wider than the parent. Don't say just say wider. You have to compare it. Wider than what? Wider than the parent. Okay? Number 3, there was no translation. It stayed the same. Okay? It didn't translate. And number 4, what was it? Oh, it's not a reflection. Not a reflection. Okay? 4 things you would tell me. Okay? Look at this one here. Letter B. Since A is negative, right away it tells me something. It's going to be a reflection. It's going to go down this time. It's going to look like this because A is negative. Okay? What else? Number 1, is it a vertical shrink or a stretch? Well, that number is greater than, absolute value of A is greater than 1, which means that is a vertical stretch. Number 2, is it wider than the parent or narrower? We say wider or narrower. It's going to actually be narrower than the parent. Then you have to write than the parent. Okay. And 3, translation. Did it translate at all? No. There's no H and K, which means there's the same vertex. You could say it's the same vertex or no translation. Okay. And lastly, number 4, it is a reflection over x-axis. Okay? There it is. Have those 4 things when you compare. Let's look at what they wrote. Okay, here's the 2 things. 1/2 x. Notice they're comparing the first one to the parent. Here's the parent. Here's the first one. Right here. Okay? It's wider. It's a vertical shrink. Okay? Alright, vertical shrink. Has those 2 things. Not a reflection. Didn't flip down. No reflection there. The second one, -3. Here's the second one comparing. So it goes down because A is negative, right? You get that? And then notice how it's like thinner than the parent. So you notice the blue parent? Notice it's narrower. We have to say narrower. Did it say that? I don't, didn't say that, but you have to say it. So 1, it's vertical stretch. Okay, vertically it's stretched out. It's like getting taller, right? And then it is reflected. There's another one. You have to say it's reflected over the x-axis. You have to say it is narrower than the parent, which we already said. Okay? And then you can say they have the same vertex. Or it didn't translate. The vertex didn't translate. Okay? That's how you do example